Welcome to Fast Math Solutions on Maths with EJD. In this video, our focus is going to shift to this. Find the cubic roots of unity. Of course, unity is 1. Cubic roots is something like this, or something raised by 1 over 3, right? For complex numbers. So find the cubic roots of unity for complex numbers. So let's see how we go about that. Okay, let's see how we go about that. Now, here it is. You have to find the cubic roots of unity, you can actually pose the problem as z cube equals 1. So it's like the complex number is z raised to power 3, and that is equal to 1. So it means you're looking for z itself now. So, and of course, you already know that in polar form, right? To get 1 in polar form, that has to be something cos something plus sine something. And that is the best way that can work is this. Cos 0 is 1, sine 0 is 0. So the complex part is gone because all we need is 1, okay? So, for instance, if you're looking for z cube equals 8, that'll be 8 will be 8 cos 0 plus I sine 0. So if it was just I you needed, that'll be, so you look for something where you can get one. So maybe cos 90 plus sine plus I sine 90. So if you're looking for I like this, so, just find a way of getting the right angle to give you what you want. So now we need 1. So cos 0 degrees plus I sine 0 degrees does the job. But, it may be a bit difficult to work with 0, but we know cos 360 degrees will give us the same, and sine 360 degrees will give us the same. So cos 360 degrees is 0, sine 360 is 1, sorry, and sine 360 degrees is 0, okay? So now you have this k here because multiples of 360 degrees too will also give you the same kind of thing. So that because if you are looking for all the cubic roots, it means you are going to get 3 results, and this k will determine the differences in the results. So let's see how that works. Generally speaking, right, we say that z raised to power n equals cos 360 degrees k plus I sine 360 degrees k, since we are looking for roots, cubic roots. And since we are looking for cubic roots, n will be 3 here, just like you see here. And because n is 3, the k will have to start from 0. So you have 0, 1, 2. So we can get 3 roots because cubic root means 3 cubic roots. So we have k to be 0, 1, 2. Now, since we already know that Z3 is what we are looking for. Z3 equals 1. And this is technically 1, right? So we have Z equals cos 360 degrees K plus I sine 360 degrees K raised by 1 over 3. So now the Morse theorem can kick in. So from the Morse theorem, so you multiply angles. What if you had R out here before, it would have been R raised by 1 over 3, but there's nothing like R, there's nothing like R. So you go inside. For you to go inside, you multiply the angles by the power. So normally you should have cos 1 over 3 times 360 degrees K. And the same for sine. That's why you have this 360 degrees K over 3 plus I sine 360 degrees K over 3. 360 degrees K over 3 is actually 360 over 3 is 120 degrees. Then that K, then I sine 120 degrees, that K. Now, to get the specific cubic roots now, you already know we are taking K to be 0, 1, 2. So we are taking K to be 0, 0, 1, and 2 because n is 3. We're talking about cubic. Okay? 0, 1, and 2. So for k equals 0 now, for k equals 0, so that means this here, k here is 0. So we have z equals cos 120 degrees times 0 plus I sine 120 degrees times 0. Very important. So then 120 degrees times 0 is 0 degrees. So you have cos 0 degrees plus I sine 0 degrees. 120 times 0, that's 0 degrees. So cos 0 again is 1. Sine 0 is 0. So one of the cubic roots is simply 1, like that. It's just 1. So that's one of the cubic roots. So we have 2 to go. So for the second one, you have k equals 1. So for k equals 1, right, you have cos 120 degrees k plus 1 I sine 120 degrees k. So now k is 1. So 120 degrees times 1 like that. So 120 times 1, 120, 120. Now, since you are dealing with 120, it's not in the first quadrant. If you look at the quadrant again, this is 0 degrees. This is 90 degrees. This is 180 degrees. And this is 270 degrees. And finally, again, 360 degrees. So you see in the first quadrant, all the trig ratios are positive. Sine, cosine, tangents are positive. In the second quadrant between 90 and 180, only sine is positive. In the third quadrant, only tangent is positive between 180 and 270. And in the fourth quadrant, between 270 and 360 degrees, only cosine is positive. But then 120 degrees, of course, sits pretty between 90 degrees and 180. So we know it's in the second quadrant. So sine is, anything sine there is going to be positive, but anything cos or tan is going to be negative, and we need cos and sine. So, but then the other issue you have to deal with is this 120 degrees. How do you break it down to something equivalent to the first quadrant? So the way to do that is just to say 180 degrees minus 120, and that is 60 degrees. So then cos 120 degrees, since cos is negative in the second quadrant, you just say, so you have minus, then it's equivalent to cos 60 degrees. And sine is positive in the second quadrant, so you say I sine 60 degrees, which is equivalent to 120. So, and of course, we know cos 60 degrees is 1 over root 2. Of course, this minus is there. And sine 60 degrees is root 3 over 2. So we can get this from this idea of equilateral triangle, right? So where each side is 2, 2, 2 all the way, okay? And then all the angles are 60, 60, 60, okay? So if you drop this now, you have this. So this angle is 30, but this is 60. So now that you're, so this line, this altitude divides this into two equal parts. So if everything is 2, it means this is, so everything is 2, right? So it means this is 1, this is 1 unit, and this is also 1 unit. So you have this 1 unit, 1 unit. So if you're looking for cos 60 now, cos 60 is adjacent over hypotenuse. That's simply 1 over 2 that you have here. Sine 60 is up, sine 60. Of course, if you need this side now, because this is 1, this is 2, from Pythagoras theorem, this is square root of 2 squared minus 1 squared. That's 4 minus 1. That's 3. So this is root 3. So sine 60 degrees is root 3 over 2. That's why we have root 3 over 2 here. So that's the second of the cubic roots, minus 1 over 2 plus I root 3 over 2. Then for k equals 2 now, for k equals 2, we have z equals cos 120 degrees times 2 plus I sine 120 degrees times 2. So 120 degrees times 2 is cos 240 degrees. Again, I sine 240 degrees. In this case, 240 degrees isn't, which quadrants we have to check again. You have 0 degrees, you have 90 degrees, you have 180 degrees. You know, it goes anti-clockwise. You have 270 degrees, and then you have 360 degrees. Now, 240 sits in the third quadrant. Everything is positive here. Sine is positive here. Only tan is positive here. And cosine is positive in the fourth quadrant. But 240 degrees is sitting in the third quadrant. Okay? So first, we know, since we are looking for cos and sine, automatically they'll both be negative because they're in the third quadrant. Then the next thing is, what is the equivalent of 240 degrees in the first quadrant? That will be 240 degrees minus 180 degrees. That happens to also be 60 degrees. That's why cos 240 degrees is the same thing as minus cos 60 degrees. Sine 240 degrees is the same thing as minus sine 60 degrees. So again, cos 60 degrees is 1 over 2. Sine 60 degrees is minus 1 over 3 root 2. I mean, it's minus root 3 over 2. That sine 60 is root 3 over 2. Of course, the minus is coming from the fact that 240 is in the third quadrant and only tan is positive there. So with that, we have got all the 3 roots of unity. So all the 3 cubic roots. So the cubic roots of unity are 1, minus 1 over 2 plus I root 3 over 2, and minus 1 over 2 minus I root 3 over 2. Those are the 3 roots of unity. Thank you so much for coming this far with me in this journey. If you have not subscribed to my channel, feel free to do that and hit the notification bell so you can get alerted anytime I release a new video. See you in the next one.